Did you know that percentage problems on the SAT math section are some of the most often missed problems, even by high scorers? I want to show you in today's video how you can get every single one of the SAT math percentage problems right if you consider the right framework. That is, every percentage problem on the SAT fits into one of two categories, and I'm going to show you how to figure out which one it is and how to get them right every single time. Here's the first problem that I want to show you. This says the number A is 190% greater than the number B. The number B is 80% less than 24. What is the value of A? This is the kind of problem that's what I call a percent increase or decrease problem. I've got two quantities here, A and B, and they are changing by a percentage. So this is what we call percent change. When you work a percent change problem, you want to always form equations using the following formula. The new value after the change occurs is the old value times 1 plus or minus the percent change expressed as a decimal. So if I take this first expression about the comparison between A and B and convert that into an equation, it says that A is 190% greater than B. So in other words, B has been increased by 190%. So the new value is A. And then what I'm going to do is say that the old number is B, and it's being increased by 190%. So that would be 1 plus 1.90. I take the 190% and convert it into a decimal, 1.90. That's what that sentence interpreted into that formula becomes. The next sentence says that the number B is 80% less than 24. So 24 has been reduced by 80%. So that would be 24, right? The new number B after the change of 24 has occurred is 24 times 1 minus 0.8. So let's rewrite these. That top equation is A is equal to 2.90 times B. And this one is simply a number. I'm going to calculate what B is, and in Desmos, we would say 24 times 0.2. We've got 4.8. And now what I'm going to do is they want me to figure out what the value of A is, so it's nothing more than doing a substitution and saying that A is equal to 2.90 times 4.8. And when we do the calculation, we see our answer is 13.92. Now that's a simple problem, but many students would miss this if they don't force it to go into this type of equation for a percent increase decrease. Let me show you the other kind of problem, and that's what I call a percentage of problem. This problem says that the positive number A is 2,241% of the sum of B and C, and B is 83% of C. So again, this is not a percent increase decrease. Nothing's going up or down by a percentage. It's a percentage of problem. And when you see those kinds of problems, you're just going to interpret the word of to mean multiplication. So this would be A equals, right? Is means equals. Converting that into a decimal would be 22.41 of what? Times, right? Of means multiplication. The sum of B and C. So that would be B plus C. Then they give me another sentence where is going to be my equal sign. B is 0.83 of means times C. And the question that they want us to answer is what percent of B is A? So the question is really wanting us to get rid of the variable C. So what I'm going to do here is I'm going to solve this equation down here for C. C would be equal to B over 0.83. And I will do a substitution. I will take that and plug it into the first equation that I came up with for the variable C and rewrite that equation. And that would be B plus B over 0.83. Now at this point, what I'm going to do is I'm going to combine these two terms together over in Desmos. So I'm going to take 1 plus 1 over 0.83, and then I could see that what we have here is 22.41 multiplied by 2.2048. And that's times b, right? Because when I combined those two terms together, I was adding the coefficients and got that coefficient there. So the equation now looks like this. Now I'm just going to take 22.41 and multiply that by 2.2048, and I get A is equal to 49.41 times B. And notice the question. Let's go back and look at the question. It says, what percent of B is A? It's going to be, that right there would be 4,941%. To multiply something by 49.41 would mean that it's 4,941% of B. Let me work just one other problem that would be a percent increase decrease problem. Here's the next problem. It says that a gift shop buys souvenirs at a wholesale price of $7 and then sells them at a retail price that is 290% of the wholesale price. At the end of the season, any remaining souvenirs are marked at a discounted price that is 80% off the retail price. What is the discounted price of each remaining souvenir? I guarantee you that 80% of students that try to work this problem are going to miss it if they don't think about percentage problems in one of two buckets. It's either a percentage of or a percent increase decrease. And in this problem, I selected this one because it has both of them. This says that the gift shop buys at a wholesale price of $7. So I'm going to let W equal $7. That's the wholesale price. And then it says that it resells them each at a retail price that equals 290% of the wholesale price. The word of means to multiply. So I'm going to write that equation, 2.90 times the wholesale price. Then the next sentence says, at the end of the season, any remaining souvenirs are marked at a discounted price that is 80% off the retail price. So that is a percent reduction. So now I'm going to interpret this and put this into that formula that I was showing you on the previous problem. So what this means is that the discounted price, let's use D for discounted price, is 80% off the retail. So I'm going to take the retail and multiply it by the fact that it is being discounted by 80%, 1 minus 0.8, which of course you know is 0.2. So we could write this as 0.2 times R is our discounted price. Now they want us to find D. Easy enough, because I'm now going to plug 7 in for W. Going over to Desmos, I will take 2.9 times 7, and I get a retail price of $20.30. So therefore, I have my final answer. The discounted price is $4.06. So you have to be alert as to whether it is a of problem, percentage of, or if it is a percent increase or decrease problem. I hope that helps students. Do lots of practice on these problems, and you can nail them every single time if you fit the percentage problems into one of those two categories.